Welcome to Autoverse. Imagine boarding a plane that emits nothing but water vapor, gliding quietly through the skies without burning a single drop of fossil fuel. It might sound like science fiction, but it's closer to reality than ever, thanks to Airbus and their ambitious ZERoe program. Today, we're taking a deep dive into the revolutionary hydrogen-powered aircraft concepts being developed by Airbus under the ZERoe name, an initiative aimed at radically transforming the aviation industry by the mid-2030s. From cutting-edge design innovations to game-changing propulsion systems, we'll explore how Airbus plans to take us into a cleaner, quieter, and more sustainable future of flight. The ZERoe project, short for Zero Emissions, is Airbus's bold answer to the growing urgency around climate change and aviation's role in global emissions. While commercial aviation accounts for roughly 2–3% of global CO emissions, its impact is projected to grow sharply as global demand for air travel rises. That's why Airbus is banking on hydrogen, not batteries, as the most viable path toward truly sustainable aviation. Unlike conventional jet fuel, hydrogen, when used in a fuel cell, emits only water, making it a highly attractive clean energy source. And with the increasing availability of green hydrogen produced from renewable energy, this isn't just a vision for a cleaner sky, it's a practical roadmap. Now, when we talk about hydrogen-powered planes, we're not just talking about one aircraft. The Airbus ZERoe program actually includes several different concept designs, each tailored to different use cases. As of the latest reveal, there are three primary aircraft concepts: a turboprop, a turbofan, and a blended wing body. Each of these serves as a potential prototype for the first zero-emission commercial aircraft that Airbus hopes to launch by 2035. Let's start with the turboprop design, which is perhaps the most conservative but also the most immediately practical of the trio. The turboprop ZERoe concept is a high-wing regional aircraft with a capacity of around 100 passengers. It uses two hydrogen-powered turboprop engines, offering a range of roughly 1,000 nautical miles, making it ideal for short-haul routes, think flights under 2 hours across Europe or within the United States. This design looks similar to today's regional propeller planes but hides a radically different energy system. Instead of kerosene tanks, this aircraft houses cryogenic hydrogen storage tanks in the rear fuselage, where fuel is stored at -253 degrees Celsius to remain in liquid form. The hydrogen is then converted to electricity using fuel cells, which power electric motors that drive the propellers. This setup not only eliminates carbon emissions but also significantly reduces noise, a huge benefit for communities near airports. Next, we have the turbofan concept, which pushes the limits a bit further. This aircraft is designed for a longer range, up to 2,000 nautical miles, and can carry between 120 to 200 passengers, depending on configuration. This makes it suitable for medium-haul routes like London to Athens or New York to Dallas. Unlike the turboprop, this design uses a more traditional jet engine layout, but with a twist. The hydrogen is combusted directly in modified gas turbines. That means instead of converting hydrogen into electricity, this aircraft burns it in a way similar to how today's jets burn kerosene, just without producing CO. It's a clever compromise that allows Airbus to leverage existing jet engine technology while still achieving zero-emissions flight. Again, the hydrogen is stored in cryogenic tanks, and special insulation is required to handle such low temperatures safely. Engineers are also focusing heavily on safety protocols, ensuring that hydrogen is managed in a way that poses no greater risk than today's aviation fuels. Perhaps the most visually striking of all is the blended wing body concept. This aircraft looks like something out of a sci-fi movie. Instead of a tube and wing layout, the fuselage and wings form a continuous aerodynamic surface. This not only allows for more efficient flight by reducing drag but also provides more internal space for fuel storage and innovative passenger cabin designs. This concept could carry about 200 passengers and has a similar range to the turbofan version. It's the most radical departure from current aircraft design, and although it's the least likely to enter service first, it serves as a glimpse into the long-term future of aviation. The blended wing configuration is particularly advantageous for hydrogen storage, as it allows for large, cylindrical tanks to be embedded within the aircraft's wide, flat body without compromising aerodynamics. From a performance standpoint, these aircraft are designed to match or even exceed current standards in fuel efficiency, speed, and operating cost over time. While the initial costs of development and hydrogen infrastructure will be high, Airbus believes that these will come down significantly as the technology matures and economies of scale kick in. One of the most compelling performance features of hydrogen propulsion is its efficiency. Hydrogen contains about 3 times more energy per kilogram than kerosene. That's huge. However, it's also less energy dense by volume, which means aircraft need larger tanks. This is where the new designs come into play. Airbus is fundamentally rethinking aircraft architecture to make room for hydrogen storage without compromising space or balance. Safety is another crucial aspect, and understandably, many people have questions about hydrogen's flammability. Airbus engineers are taking cues from other industries, like automotive and space exploration, where hydrogen has been used safely for decades. Advanced leak detection systems, double-walled tanks, and automated safety valves are just a few of the technologies being employed to make hydrogen as safe, if not safer, than conventional fuels. Moreover, hydrogen rises quickly and disperses in the air, unlike liquid fuels that pool and can create persistent fires. Airbus is also working closely with global regulators to create new certification standards specific to hydrogen-powered aircraft. One of the unique selling points of the ZEROe aircraft lies not only in their clean operation but also in their potential to transform the flying experience. Imagine quieter cabins, less turbulence due to innovative wing configurations, and even reimagined seating layouts thanks to non-traditional fuselage shapes. In the blended wing body, for instance, passengers could enjoy panoramic views, social lounge spaces, and more spacious seating arrangements. Airbus is not just building a cleaner aircraft, it's rethinking what flying could feel like in the 21st century. But perhaps the biggest challenge, and opportunity, lies not in the aircraft themselves, but in the ecosystem around them. For ZEROe to succeed, airports will need to adapt to handle hydrogen refueling. This includes building infrastructure for hydrogen storage, delivery, and safety. Airbus is already working with airports, energy companies, and regulators to develop these systems in parallel with the aircraft. Several testbeds are being developed, and Airbus plans to start ground and flight testing of hydrogen systems in modified A380 test aircraft by the late 2020s. These tests will validate everything from engine performance to cryogenic fuel handling to in-flight safety protocols. The public and political momentum behind this project is also noteworthy. Governments across Europe and beyond are increasingly mandating sustainable aviation goals, including zero emissions targets for domestic flights. Airbus's ZEROe concepts position the company as a leader in this emerging space, giving it a first-mover advantage in what could become the largest disruption in aviation since the jet engine. By committing to a 2035 entry into service, Airbus is setting a tight but achievable timeline, one that aligns with broader goals under the Paris Agreement and the European Green Deal. And let's not overlook the broader economic and environmental implications. If Airbus succeeds, hydrogen-powered aviation could significantly reduce the carbon footprint of air travel, stimulate new industries in green hydrogen production, and create high-tech jobs across the aerospace, energy, and infrastructure sectors. It's a holistic approach that extends far beyond the aircraft themselves. In fact, Airbus envisions a future where hydrogen becomes the backbone of a clean mobility system, powering not just planes, but also ships, trucks, and even cities. To summarize, the Airbus ZEROe program is a fascinating, ambitious leap toward a cleaner future of flight. With multiple aircraft designs exploring the use of hydrogen in both fuel cell and combustion formats, Airbus is hedging its bets across a spectrum of technologies, each offering different strengths for different market segments. Whether it's the near-term viability of the turboprop, the long-range potential of the turbofan, or the futuristic design of the blended wing body, each ZEROe concept is a step toward decarbonizing aviation. Combined with collaborative efforts to build a supporting hydrogen infrastructure, Airbus is positioning itself not just as an aircraft manufacturer, but as a leader in sustainable innovation. Of course, there's a long road ahead. Many technical, regulatory, and economic challenges remain. But the trajectory is clear. The future of flight is zero emissions, and Airbus is betting big on hydrogen to get us there. Whether or not these concepts become the exact aircraft that enter service in 2035, the work being done now will almost certainly lay the foundation for the next era in aviation history. Thanks for watching. If you found this video helpful, informative, or just fascinating, make sure to like, subscribe, and turn on notifications for more deep dives into the future of technology and transportation. Got questions about hydrogen aircraft or thoughts on the future of sustainable aviation? Drop them in the comments, we'd love to hear what you think. Until next time, keep your eyes on the skies.